Doesn't your brain need cholesterol? I get this question literally every single day. Doesn't your brain need cholesterol? Why should I lower my cholesterol? Isn't that going to affect my brain, my testosterone, my hormones, all that kind of stuff? So yes, your brain needs cholesterol. In fact, your brain is a huge hunk of cholesterol. Obviously, there's other things in there, but people don't seem to understand that the circulating cholesterol in your bloodstream has nothing to do with the cholesterol in your brain. They are completely separated by two compartments. There's this thing called the blood-brain barrier, or the BBB. The blood-brain barrier does not allow circulating cholesterol that travels through your arteries, these lipoproteins, high density, low density, etc., does not allow cholesterol-containing lipoproteins to enter the parenchyma, which means like the cells, the myelin sheaths, the astrocytes, the oligodendrocytes, all of that in your brain. There's no connection. However, the lipoproteins that feed, the arteries that feed your brain do contain lipoproteins, and as we have seen, and as is obvious, the lipoproteins in those arteries going into your brain, like your middle cerebral artery, your carotid arteries, your posterior cerebral, cerebellar arteries, frontal, all of that, all of those can plug up. And that's why a lot of people with high cholesterol get dementia or dementia-like symptoms, because their arteries are plugging up. They have all these small little strokes or mini strokes called lacunar infarcts. And these infarcts or strokes are caused by the blood flowing in the lipoproteins in your blood going through the arteries that flow or go to feed your brain. Now, for those of you who don't know me, I'm Dr. Allo. I'm a board-certified cardiologist. I wrote the book on cholesterol. I'll put it up here. I wrote this book with Dr. Thomas Dayspring. He was the lipid and lipoprotein editor. He was actually the brain editor too. He wrote the majority/edited the majority of the brain parts, and he has some beautiful illustrations from the book. I'm going to put them right up here. But the book is called Cholesterol Truths. You can grab it on Amazon. Within the first week of release, it was the #1 book for sale on Amazon in heart disease, and I would highly recommend that you grab it if you want to go deep into this. Now, I'm going to divide this up into two different sections, which I've kind of been doing with most of these videos. One is kind of the layperson's explanation of cholesterol, the brain, etc., and then we'll dive into the studies and go into details, which is from the book. It's like directly from the book. A lot of you guys in the comments are saying, "Are you just trying to sell cholesterol books?" No, I'm not, people. Every single chapter from the cholesterol book is on my blog in some shape, form, or other. And a lot of times it's exactly that chapter, just cut and pasted with the beautiful illustrations and everything. So not trying to sell you any books or any nonsense. Some people wanted a printed book. It's a nice coffee table book. It's 520 pages, full color, 8.5 by 11, like a huge, gigantic book. Some people just wanted that. I highly recommend it. It's got some great reviews. But that's what I would recommend if you are like a cholesterol enthusiast. Now, I haven't had time to get every single chapter up there. It's a lot of chapters. It's like almost 30 chapters, but I've gotten several of them up there, especially the more important ones, like does sugar cause heart disease? Does statins cause dementia, et cetera, things like that. So the most important ones, the ones that seem to have the answer to the most questions that you all might have, are on there. But the rest of the chapters are slowly getting up there. I'm just a one-man show. I don't have this giant team. Everybody's like, "Oh, can you tell somebody from your team to reach out to me?" I'm like, the team is me. I'm the team. If you want me to reach out to you, I will try. Maybe I need a team. I don't know. But I'm going to try my best to answer all of your questions and comments. Every once in a while, I log in here and try to answer as many comments as possible. So let's get back to the brain and cholesterol. Yes, your brain is made of cholesterol. Obviously not the arteries that are in your brain, but like the myelin sheaths, the parenchyma of the brain, which is like the actual brain tissue. There's gray matter, there's white matter. A lot of that is made of cholesterol. The cholesterol in your brain has a very, very, very long half-life. We're talking like 5 to 7 years. So if you're younger, if you're like a 20-year-old or perhaps a 30-year-old, maybe even 35, much of the cholesterol that is in your brain was there since infancy, since birth. So And the thing is, like, when your cholesterol levels start to go down or cholesterol synthesis drops, your brain just starts to ramp up or slow down synthesis depending on what it needs. And we'll get into the meticulous details once I get into the chapter part of the book where I read that to you. The other thing that's super important is that when humans need the most amount of cholesterol, that is to form your brain and your nervous system and all of that, is generally in the womb and those first few months of life into like the first year or two of life. And that is when your cholesterol is actually at its lowest. A lot of people say, well, don't you need cholesterol to make brain and brain tissue and nervous tissues and myelin sheaths and all that? Yes, you do. And they're all made out of cholesterol. And guess what? When your body is busy making all that stuff, that's when your cholesterol is actually the lowest that it ever is. You're talking LDL cholesterol in the 15 to maybe 35, 40 range at the most. We call that physiologic. Not because of, that reason alone that newborns have low cholesterol, but because we have found that the amount of cholesterol that your body needs to function is somewhere in the 15 to maybe 35, 40 range at the most in order to just, function and keep the lights on. Not that you need any, because we have lots of people that are born with a condition called hypobeta-lipoproteinemia, which I've discussed extensively in another video. These are people that walk around their entire lives with cholesterols, LDL cholesterols in the 5 to maybe 15 range at the most. Like, even if they did everything wrong and consume the worst diet in the world, they really cannot get their LDL cholesterol levels much higher. These people live their entire lives without atherosclerosis. So super interesting genetics there. It's almost like the opposite of familial hypercholesterolemia, where these people are born with insanely high, genetically high cholesterol levels, anything from the 190 milligram per deciliter range up to the 3, 4, 5, 600 range, sometimes depending on whether they inherited one gene or two genes, one allele, two alleles, whether they're homozygous or heterozygous, what have you. But those are like kind of the two opposite extremes. You have the almost like a PCSK9 loss of function mutation, and then LDL receptor mutations way up here. I'll put the graphics up here of all the various genetic mutations. But brain cholesterol is a super interesting question, because I get a lot of these questions where people are so confused as to why would we want to drive people's cholesterols down with statin medications, with whatever, if your brain is made out of cholesterol and we need cholesterol. They also ask the same thing about testosterone and estrogen and hormones, vitamin D, all that kind of stuff. And every cell in your body has cholesterol in its cell membrane. So they say, isn't it essential for life? Well, lots of things are essential for life that can also kill you, like, for example, water. 2/3 of the human body is probably water. And maybe some people will say that it's not true, but regardless, a huge portion of you as a human is water. If you consume water too quickly, what happens? You drink too much water too quickly, you get very hyponatremic, you can have seizures, and you can even die. This happened in the 90s when I was in high school, when somebody did this Nintendo challenge. You do this, you drink a gallon of water as fast as you can, and you win a Nintendo, and kids died. So not a good outcome. But the cholesterol in your brain makes, every cell in your body makes its own cholesterol, including your brain. And we'll get into the details in a little bit. You do not need anything to stimulate your body to make cholesterol. Every cell in your body, all you need is a citrate molecule and an acetate molecule, which every cell already has. You do not need to encourage this. You do not need to stimulate it. You do not need to eat citrate or acetate. Your cells already have these little molecules, and through the various synthesis pathways, block, and the other ones, I'll put them up here too, you can actually make your own cholesterol. Every cell makes it. The problem is we have too much, and then how do you get rid of it? They package it up into LDL and HDL lipoproteins, and they ship it off into your bloodstream, and it's supposed to go to your liver and be eliminated. Now, the problem is, before it gets to your liver, it's circulating in your bloodstream, and it can deposit in your carotid arteries, the arteries that go up into your brain, the arteries in your heart, and that's where all of the problems begin. Over a certain concentration gradient, LDL lipoproteins, low-density lipoproteins, begin to deposit in your arterial wall. And that number seems to be about 60 milligrams per deciliter. The Jupiter trial found about 57. The PISA trial was around 60, or you could even argue 55. Below about 60, or let's say 55, there was no atherosclerosis. Above that number, people were building cholesterol deposits in their arteries and having atherosclerosis. It can be in your peripheral arteries like your legs. It can be in your brain, which gives you strokes, and it can be in your heart, which can give you heart attacks. And it can happen everywhere else, kidneys, other areas. Usually the arteries in your heart and your brain are the smallest, which is why heart attacks and strokes usually manifest first. Peripheral artery disease and some of these other things, because the arteries are larger caliber, larger lumens, you generally don't have that issue as much, or it takes a lot longer to occur because they are larger and it just takes longer to happen. So there's that. Now the next question is, do any of the medications lower cholesterol in your brain? So the answer is yes. Statin medications, all of them, whether they are lipophilic or hydrophilic, lipophilic meaning loving fat, hydrophilic means loves water. There was this thought early on in the cholesterol pathways when we were making cholesterol medications, not me, but like pharma, when, pharmaceutical companies were inventing these medications, which they weren't really inventing. They discovered it from yeast or fungus. So they were just kind of redoing the molecules, purifying them, and trying to find a way to make it so it's not toxic to your kidneys or your liver, because there have been other molecules in yeast itself that were toxic to kidneys and liver, and they had to, get rid of those. But in order to purify just the molecule that works so it doesn't cause damage, they were able to do that. And sometimes the pharmaceutical companies will say, well, ours is lipophilic versus theirs is hydrophilic and whatever, to try to market it slightly differently. We have found that all of them do cross into the statins. All of them cross the blood-brain barrier and can slow down to a certain extent cholesterol synthesis in your brain. Now, it's not a huge effect because your brain can ramp up or slow down cholesterol, and because the half-life is so long, it almost doesn't matter. Now, do some people get some weird symptoms when they take statins, like brain fog and things like that? Yeah, it's reported. The amount of these, when you look at studies that compare actual real symptoms of dementia, brain fog, neurocognitive decline, it ends up being less than 0.34% of the people on statins. The worst offending statin for all of these side effects was Zocor or simvastatin, which really no one should be on anymore. But that one was the worst offender with a 0.34% risk of many of these side effects. The more modern statins like atorvastatin, rosuvastatin, pitavastatin generally do not have these side effects. Atorvastatin and rosuvastatin are the main ones we use now because they're very potent. Crestor or rosuvastatin being the most potent. It's the newest, most synthetic one that is also the most potent. Pitavastatin is also synthetic. It's just a little bit more potent than pravastatin, which is one of the older non-synthetic statins. The older ones would be like lovastatin, pravastatin, which is Pravachol, lovastatin was Mevacor, Zocor, which is simvastatin, and then pitavastatin, semi-synthetic or synthetic. You could qualify it as a little bit of both, but it's another newer synthetic one that is just a little bit stronger than pravastatin. The weakest one, probably you could argue, is Lova or Prava. Lovastatin probably, then Prava, then Simva, then Atorva, then Rosuva, and then you could throw pitavastatin. It's still not generic yet, so no one really uses it. Doctors don't just use medications because they're expensive. We use the generic cheap ones when we can. No one gets paid to prescribe generic medications or any of that. You could easily look this up online. It's free information. But the rosuvastatin is the most potent and generic, and it works fantastic, and it has great outcomes, very well tolerated, super safe, almost no issues with it. It's the one we reach for first. When you combine that with something like Zetia, which blocks absorption of cholesterol from your intestines, you get a very potent effect without a huge effect on without a huge side effect profile, let's put it that way. But when you look at very well-controlled studies where the person either knew or didn't know they were on the medication or they were on placebo, you had a 0.3% amount of people that got the muscle aches. The biggest thing is the muscle aches. The more recent studies that I posted, I think I have a few videos on these, was do statins cause dementia? Do statins cause cancer? Does lowering cholesterol, does low cholesterol cause cancer, etc.? It turns out that statin medications, first of all, they reduce all-cause mortality in nearly every study that's ever been done. They reduce cardiovascular mortality. Obviously, they have been shown to add decades to people's lives, not because we actually have those studies. We have the 20-year data on the WASCOPS trial with a 6% absolute reduction, etc. But projection models based on what we have today have shown that we're adding probably decades to our lives and quality of life. But that's kind of besides the point. They looked at studies, they looked at neurodegenerative, all forms of neurodegenerative disorders. These are brain disorders. These are like Alzheimer's, Parkinson's, multiple sclerosis, mild cognitive decline, dementia, Alzheimer's, all of that. They looked at like 5-6 different things, and I have a whole video on that. And it's on my blog. If you go to drallo.net/blog, just search dementia. You'll get to that article, beautiful graphics showing the significant reduction. Anybody on a statin of any kind had a significant reduction in all forms of neurocognitive or neurodegenerative disease. And in fact, the Lancet recently, as last year, 2024, and this is in the book, this is in the cholesterol book. People say, well, you're just looking at old studies. You never looked at any new studies. The Lancet study was published as the book was being written, and the book was rewritten to include the Lancet study. The Lancet published a study. The study wasn't even available to the public yet. It was pre-proof edition. It was published, but in a future edition. So we had to go ask them to please send it to us so that we could include it in the book. But 2024, the Lancet said, tied for first place, the number one risk factor for Alzheimer's and dementia and all of these things was high LDL cholesterol. So there's that. So if I were to conclude at least this first part of the video, it would be that, number one, statins are super safe. Number two, they all do cross the blood-brain barrier. Number three, they can reduce some synthesis in the brain for cholesterol, which is why we have other medications. We have bempedoic acid, which only affects synthesis in the liver. We have PCSK9s, which affect clearance of cholesterol. We have all kinds of other options. Zetia reduces absorption of cholesterol, or I should say reabsorption of cholesterol. So there are other options if this is like scaring you or worrying you. There's no excuse in today's modern world for anybody to say, well, I don't want to take anything because of XYZ. So there are lots of options. But those are kind of the things that we do know. They do all cross the blood-brain barrier. They have a minimal effect on brain cholesterol synthesis. You can measure brain cholesterol synthesis by using desmosterol. And there's a huge part of the chapter in the cholesterol book, which I'm going to read in a second here, that goes through that, the desmosterol pathway and how we can use that as a surrogate for brain synthesis if you want to. Now, no organization or guideline recommends this as of yet because it just hasn't been proven over time. You need multiple validated studies to show that checking this actually improves outcomes or has a benefit or whatever it might be. So, if you're on the cutting edge of this kind of stuff and you really want to check a desmosterol level, you can. Not sure what we would do with it. If it's like really low, you could argue that brain synthesis is kind of halted. You might want to take off the statin for a while, switch to something else. I don't know. Now, if you have really high cholesterol, then it's not worth it. You just need to get your numbers down because getting infarcts and lack of blood flow to your brain is probably a lot worse. So I'm going to end this part of the video here. If you are more of an enthusiast and want the details, I'm going to put up the beautiful graphics from the book up here that the enthusiast type person who wants the nitty-gritty details will enjoy. But I'm going to read to you this section of the book. This is actually chapter 14 out of, I think, 27 total chapters, maybe 30. The last few chapters are really cool. They're like, when do you need a stress test? When do you need an echogram? If you pass out, what should you do? Who needs a Holter monitor, a loop recorder? Who needs a cardiac catheterization? Pictures of it, what it is, when to do it, what it means, CT scans, calcium scans, whatever. And then the last chapter is a bunch of case studies. You got a 27-year-old male. His LDL is XYZ. He works out. He eats right. He doesn't do anything different. He's built. He's strong. What do you do in this scenario? You have a 65-year-old male who had open heart surgery and had bypass, had whatever. Here's his numbers, a little bit diabetic, a little bit of this, a little bit of that. What do you do in that scenario? So super cool chapters, but this is chapter 14 of the book. It is called Statins, Cholesterol, and Your Brain. Now, it is addressed somewhere else in the book too, called Do Statins Cause Dementia? I think I have a separate video on that. You can go watch that one, Do Statins Cause Dementia? There is an entire video on that. And if you are part of the lipid masterclass on my website, I have a lipid masterclass. Just go to drallo.net, click on the store or click on the cholesterol masterclass. Right now it's currently on sale. We always have like these little sales. Normally it's a $500 or $600 program. It has almost every video I've ever done at any medical conference about lipids, advanced lipid testing, cholesterol, all that kind of stuff. Plus all of Dr. Thomas Dayspring's videos, animations, lectures, podcasts, what have you. All of that is all in the app. If you go to Dr. Aloe, if you just download the Dr. Aloe app, just search on your phone, Dr. space ALO, Dr. space ALO, Dr. Aloe. Search for the Dr. Aloe app. You can grab the cholesterol masterclass from there, and you get access all in one place of all of Dr. Thomas Dayspring's lectures, all of my lectures, all of my talks, all of my presentations, everything I've ever done to, and some of these presentations were given to actual cardiologists, and a lot of his presentations were given to actual lipidologists. So you're getting two of the, I think, greatest minds on cholesterol, atherosclerosis, heart disease, talking about heart disease in ways that if you're a super enthusiast, it will be in there. Plus, you get a bunch of videos for lay people. You know, if you're a person who's not a super enthusiast, you're not a scientist, you're not going to understand the studies, you get a video sort of like this, where it's like, hey, here's what we know about the brain. Here's what we know about statins. Here's what we know about treatment. Here's how we diagnose it. Here's what we do. So I think there's something in there for everyone. You know, people told me that course should cost like $5,000. Like, no. I'm not here to make any money. I just want people to enjoy it and learn and benefit. And if you download the Dr. Aloe app, there's probably 14 or 15 different courses that are all free. There's an exercise program, atrial fibrillation, hypertension, EKG masterclass, diabetes, hypertension, DVTs, clots, pulmonary embolism, stress testing. There's all kinds of really neat, cool stuff that is all completely free. I just want people to be educated and kind of know about these topics. So here's the chapter. It's chapter 14. It's called Statins, Cholesterol, and Your Brain. Before diving into dementia and medication effects on the brain, it's important to understand a bit about the brain. The brain is composed of arteries that allow for blood flow to the brain, as well as the parenchyma or brain tissue, the white and gray matter. LDL particles cannot cross the blood-brain barrier, BBB. Crossing the blood-brain barrier would mean they would cross from the arteries into the brain tissue. Very few things can cross the blood-brain barrier. This is to protect the brain. Many small molecules, glucose, electrolytes, etc., can pass through the blood-brain barrier, but large macromolecules or protein cannot. Lipoproteins in circulation do not cross into the brain. Small apolipoproteins or apolipoproteins like the C family or the ApoA1 or even tiny HDL particles can cross the blood-brain barrier, but not ApoE or ApoB particles. The tiny HDL particles that can cross are usually cholesterol-free and minimally phospholipidated particles. This does not mean that lipoproteins do not circulate in the arteries that supply the brain. They do, and these are like the arteries, like I said, the carotid arteries, the middle cerebral arteries. These are the arteries that go into the brain. We're talking about the lipoproteins getting out of the arteries and into the brain tissue, which they do not. They stay in the arteries. So this is what we're talking about here. This does not mean that lipoproteins do not circulate in the arteries that supply the brain. They do, and they can lead to atherosclerosis of the arteries in the brain. This can lead to many small strokes, lacunar infarcts, and other types of ischemic strokes. This causes vascular dementia. Reducing overall LDL cholesterol and ApoB will reduce the incidence of vascular dementia, as well as many other forms of cognitive decline. The blood-brain barrier also keeps plasma, ApoB-containing lipoproteins, out of the brain parenchyma, the brain tissue. You don't have to worry about high LDL cholesterol, high LDL particle counts, or ApoB levels in circulation having a major effect on brain cholesterol levels. The brain synthesizes 100% of its own cholesterol. The brain makes a lot of cholesterol, more than any other organ. A unique trait to the brain is that cholesterol in the brain has a very long half-life. Cholesterol in the brain has a half-life of 5 years, and much of the cholesterol synthesis occurs in utero, infancy, and childhood as myelination occurs. Myelination is the white coating kind of over the nerves, like it encapsulates the nerves, whether they're in your brain or traveling through your body. Because the half-life of cholesterol is so long, the rate for continued synthesis slows. Initially, the cholesterol production is done by oligodendrocytes. These are specialized brain cells that make myelin, astrocytes, and neurons. Later in life, astrocytes supply the neurons with cholesterol. Myelin is a type of cell that surrounds neurons. Below is a graphic that depicts the cholesterol synthesis and metabolism in brain cells. And I'm going to put these up here because these are beautiful graphics that Dr. Lipid, or Dr. Thomas Dayspring, he goes by Dr. Lipid on X or Twitter, that he created. He's one of the greatest, not only lipidologists, but lipid lipoprotein graphic designers. So he let us use these graphics in his book, obviously. So these are beautiful, beautiful graphics, and we go through and talk about some of how they're used or what happens in the brain. Neurons, not astrocytes, have the enzyme CYP46, which is 24S hydroxylase, which can convert unneeded cholesterol to oxysterols, basically bile acids. Primarily 24S hydroxycholesterol, which, due to its hydrophilic structure, can more easily, compared to hydrophobic lipids, pass through the blood-brain barrier and bind to plasma lipoproteins and are then returned to the liver. So it's a way of kind of eliminating cholesterol out of the brain as needed. Just like lipoproteins return all cholesterol back to the liver to eventually turn into bile acids and be secreted or excreted, it's a similar process here. The expression level of cholesterol 24S hydroxylase is much higher in neurons than in glia, and therefore most 24HC, 24-hydroxylase, in plasma, or 24-hydroxycholesterol, 24-hydroxycholesterol in plasma has a brain origin. Once 24S hydroxylase cholesterol crosses the blood-brain barrier and goes from brain matrizome to blood via the blood-brain barrier, it jumps on ApoB particles, which are cleared by the liver. Oxysterol then acts as a bile acid precursor. Astrocytes, the major cell that produces cholesterol in adult brains, uses the block synthesis path that goes through desmosterol. See below for the block pathway. The final step before cholesterol is desmosterol. And this is kind of what I talked about earlier, and I'll put that graphic up here as well. You'll see that everything starts with kind of the last few stages, at least, start with lanesterol. There's the Candish-Russell pathway and then the block pathway. Both of them come down to finding like a desmosterol, and the block pathway is the one mainly used in the brain. The final step before cholesterol is desmosterol, which is why sometimes measuring that seems to let us know if the brain is synthesizing cholesterol like it should be or not. Brain tissue in Alzheimer's dementia patients is depleted in desmosterol. Because of this, desmosterol levels are also low in cerebrospinal fluid. So if you measure CSF or cerebrospinal fluid, it'll be kind of low in desmosterol. That's what this is trying to say. This is reflected by low desmosterol in plasma, which is serum. And this is the one we can easily measure with a blood test. Serum just means blood. We can measure serum desmosterol. Serum levels of desmosterol correlate highly with cerebrospinal fluid levels. Low desmosterol, reflective of low brain cholesterol synthesis, is associated with both mild cognitive impairment and Alzheimer's disease. This is quite plausible, as the brain's only source of cholesterol, which is needed for neuronal function, is cholesterol synthesis. So the brain cannot get cholesterol any other way. It has to make it, which is why if the desmosterol levels are low, it can kind of tell us that the brain might not be really functioning as well as it should be. By far the most common cause of reduced desmosterol is statin therapy, because like I said, all statins do cross the blood-brain barrier, even though some pharmaceutical companies tried to market theirs as not. Should we monitor desmosterol, a biomarker indicative of cholesterol synthesis, in patients using statins? If so, when it is oversuppressed, should we reduce the statin dose and use other medications? This may be the future of treatment. Like I said, right now, definitely not recommended by any guidelines, and there's just not enough data and evidence. Like most things in science, we'll eventually need to see the data, and it might take years, sometimes even decades. But once we have the data that fully supports this, obviously this would be a recommendation. This may be the future of treatment. Brain lipidology is the last frontier that needs to be investigated, and until it is, guidelines will not be issuing recommendations on treating brain cellular lipid health. Of course, current guidelines do recommend LDL cholesterol control to reduce strokes, and maybe soon to reduce like Alzheimer's and other neurocognitive diseases based on like all of the studies that I've gone over and discussed a little bit in here, and obviously very in depth in various parts of the book. Statins can cross the blood-brain barrier and reduce overall cholesterol synthesis in the brain. The brain must synthesize its own cholesterol. There's no other way for the brain to acquire cholesterol. It cannot be trafficked into the brain via plasma lipoproteins. The only cells that get triglycerides are muscles and adipocytes, which are fat tissue, fat cells. Other than steroidogenic tissue for use and adipocytes for storage, no cell other than intestine and liver gets a delivery of cholesterol. So what we're saying here is that steroidogenic tissue, this is like your testicles, ovaries, adrenal gland, etc., they need to use cholesterol for synthesis. They can make their own and occasionally sometimes get it from an HDL particle, which we go into in a different section of the book, but this kind of is referring back to that. So you'll notice a lot of parts of the book sort of refer back and forth to each other, even though we did try to make every chapter sort of independent, which is why you can kind of read these chapters and put them on the blog as separate blog posts, and they would still kind of work if you didn't read the entire book. Steroidogenic tissue get cholesterol from HDL particles, not ApoB or LDL particles. The liver and intestines get cholesterol from both ApoB and HDL particles. The brain does not have any triglycerides as they are much too big and hydrophobic to cross the blood-brain barrier. The brain uses glucose for fuel, which is why like some of these low-carb people make no sense. The brain likes to use glucose for fuel. Obviously, your body can make glucose when it needs to. Your liver can. You don't need to consume it, but why are you making your body work overtime or make its own glucose when you can feed it glucose? Especially if you're an athlete, which I get into in some of my videos on athlete performance. I'm also a certified personal trainer, obviously. I've coached thousands of athletes and have published tons of videos and articles and what have you on athlete performance. Sometimes during Ramadan, when you're like completely fasted and depleted, like, 18 hours a day of no food, no drink, as well as like other times when you're fully fed. So highly recommend you go watch some of that stuff on here too. The brain does not have any triglycerides as they are much too big and hydrophobic to cross the blood-brain barrier. The brain uses glucose for fuel. One way to avoid statin medication's effects on brain cholesterol synthesis is to use medications that do not reduce cholesterol synthesis in the brain. Bempedoic acid does not reduce cholesterol synthesis in any other tissue other than the liver. It's very liver specific. PCSK9 inhibitors also do not reduce cholesterol synthesis, but work by increasing the lifespan of LDL receptors in the liver to increase LDL particle clearance. The receptors are in the liver, they grab LDL particles out, and they clear them. They reduce the rate at which LDL receptors are catabolized by the liver. They make it so that the liver doesn't destroy every LDL receptor. It recycles it back into circulation quickly to go grab more LDL particles, bring it in, destroy the LDL particle, but not the LDL receptor. PCSK9 inhibitors have no effect on cholesterol synthesis in any organ. And I'm going to put the graphics up here of the plasma desmosterol levels in controls, mild cognitive impairment, and Alzheimer's disease patients. Again, this is a super beautiful graphic from the book that Dr. Thomas Dayspring had sent me, and we included it. He was I wrote this chapter, but he heavily edited it, sort of like, many parts of the lipoprotein sections especially. But this is a super cool graphic. You could pause the video here and kind of read through it. It's a really cool graphic that shows you kind of the amount of desmosterol versus, how much dementia or Alzheimer's they have. So the next graphic I'm going to put up is the lipoprotein pathways in the brain. And as you can see, there's an astrocyte, there's what's called the matrosome, or this like fluid-like kind of mesh, or like, spaces in between the cells. And then there's the neurons. And you can see the ApoB particles and, how the astrocytes can make, various things, and then how they hydroxylase the 24S hydroxylase or hydroxycholesterol even, eventually turn into like these bile acids and then get excreted. It's super cool. I'm going to put that one up here too. You can kind of pause it and read through it because it's a little bit graphic and text intensive, more so than some of the other ones. But this is for the person who wants to deep dive into cholesterol, into the brain. Pause it here and kind of read through this. So hopefully, and there's another chapter in the book that I think I've already posted as a video on statins and dementia, and like what do the data show and how it doesn't really cause dementia, and if anything it actually helps it, etc. That is also a video that I've already posted, and it's already on my blog. You can go and watch that section if you have questions about that. So hopefully this gives you a better appreciation for cholesterol, lipids, brain. Does a brain need cholesterol? Does your body need, cholesterol, hormones, etc.? There's always a lot of these people online. They're trying to sell you some supplements or some nonsense telling you, well, you need this for your brain, and you need cholesterol. Buy my supplements. Don't listen to doctors. They don't know what they're talking about. You're going to take statins and it's going to fry your brain. Well, it turns out it's actually the opposite. You take statins and it actually keeps your brain functioning a lot better for a lot longer, and it seems like it has some kind of correlation with much reduced cancer risk. So you can look at that article and video on my blog as well. Hopefully this has been helpful. One thing I will recommend for those of you who are like really deep into longevity and health and really want to get better and improve their health, I highly recommend you join my community. If you go to drallo.net/community, you can join my community. This is a place where we meet every single Monday night on Zoom. All the previous Zooms are recorded and uploaded into the app. You can access every Zoom in the app, and you can text me and talk to me all day, all night in the app. It's like having a cardiologist on call all the time. What better is that? I'm a chef, I'm a bodybuilder, I'm a certified personal trainer, a cardiologist, metabolic, everything. So if you like this kind of stuff, download the Dr. Allo app and you can kind of jump in on all this stuff. We'll see you on the other side.